To make our lab more interesting, we have added R3 to the mix. It is receiving a UDP stream from the traffic generator and passing it on to R2. This traffic averages about 64K and ranges between about 40K and 72K. Since the clock rate between FRS and R2 is only 250K, FRS cannot guarantee all of the traffic from both sources. We will configure policing on the port connected to R1 with a CIR of 192K and a burst of 250K. We will configure the R3 port with a CIR of 56K and a burst to 72. As long as the combined traffic is less than 250K, all traffic will be sent. But any traffic over CIR will be marked discard eligible. First, we change the policing parameters applied to R1. We have a CIR of 192K. Our committed burst is set to 24K. This results in a TC of 1/8 of a second, or 125 milliseconds. The excess burst of 7,250 bits is 1/8 of our 58K excess burst. Added to our 192K CIR, the 58K burst takes our peak value to 250K. Here are the policing parameters for R3. Note that by setting BC equal to CIR, we're using a time interval of 1 second. This is to compensate for the low packet rate. This map will transmit packets up to 56K, mark traffic DE between 56K and 72K, and will drop traffic above 72K. Next, we apply it to interface S2 and enable policing. This is the port connected to R3. And we clear the counters. Now let's verify our policing, checking the PVC counters. First we'll check 102. For R1, about 744 packets have been received up to the 192K CIR. 202 packets have been sent between 192K and 250K and have been marked discard eligible. About 210 packets have been dropped because they exceeded the 250K rate. Let's examine PVC 302 to R3. Note that about 800 packets have come in under the 56K rate. About 100 have come in between 56K and 72K. They've been marked discard eligible. And about 76 packets have come in when the rate was above 72K. These have been dropped, again as you see here. Let's take a look at the output interface S1, which is connected to R2. We see here that output has averaged about 248K over the last 30 seconds. This is near our maximum of 250K, about 31 packets per second. Let's take a look at the output queue. At the moment, the output queue has 61 packets in it, and the full size of that queue is 64 packets, so it's definitely buffering traffic above the 250K rate. This output interface is clearly being congested. In the next demonstration, we'll show you how to manage the congestion by dropping packets marked discard eligible. As a frame relay provider, we are guaranteeing R1 that we will deliver up to 192K of traffic, and R3 up to 56K of traffic. We are permitting both R1 and R2 to burst beyond the guaranteed rates, but if the total exceeds 250K, some traffic will be dropped. Traffic from each sender that was above the guaranteed rate and below the excess burst rate has been marked DE on ingress. We will now implement a policy that drops all traffic marked DE when S1 becomes congested. To configure an output interface to drop traffic marked DE when congested, you configure a DE threshold under the interface. First, you go into the Frame Relay Congestion Management interface. Note that we've set our threshold to 50%. By default, the output queue holds 64 packets. By setting the threshold to 50%, we will start dropping packets marked DE as soon as there are 32 packets in the queue. Let's examine the output queue on S1. Notice that at the moment we have 17 packets in the queue. Let's take another measurement. Now we have 28, so the rate seems to be increasing. The rate is now decreasing and we're emptying the queue. But notice that the queue never exceeded 32 packets in depth. By marking and dropping the out-of-profile traffic, we protect the traffic sent within CIR. By setting the ECN threshold on the output interface of FRS, we can mark traffic with the forward explicit congestion notification, or FECN bit, when the interface is congested. When return traffic arrives on this interface with the FECN bit set, the switch will mark backward explicit congestion notification, or BECN bit. If we configure adaptive traffic shaping on R1 and R3, then they will reduce their sending rates to the guaranteed rates, min-CIR, alleviating the congestion. To implement this on the switch, all we need to do is add the threshold ECN command to our congestion management configuration. We are setting our threshold to 10% so that the FECN and BECN bits will be set as soon as we experience congestion. Our DE threshold remains, so our out-of-profile traffic will still be dropped if the senders do not back off. Let's check to see if the FECN and BECN bits are being set. First, we'll do Show Frame PVC 201. This is the output PVC to R2. Notice that over 1,300 packets have had the FECN bit set. Now let's check PVC 102, which is destined to R1. Notice that outbound S0 toward R1, FRS has set the BECN bit on a total of 283 packets of return traffic. Now we'll implement adaptive frame relay traffic shaping on R1. First, we create our map class frame relay. We'll call it adapt R1. We're setting our target rate to 250K, but our min-CIR is 192K, which is our guaranteed rate. If R1 gets BECN signals, it'll throttle back to this value. Here we're enabling adaptive shaping using beckons. Let's go to FRS now and check the input rate from R1. Note that we've throttled back to just 194K. Let's take another measurement, 193K, and now all the way back to 192. Let's make sure it doesn't throttle back any further, because that is our guaranteed rate. 191, 192. So it's throttled back to the min-CIR. Let's take a look at the PVC here to see the beckons that it's received. It's received 515 packets set with the beckon. Let's see if it's still receiving them. 538, 552. So it's still receiving beckon bits, and it's still staying throttled back. Let's take another look at its input rate. Still about 192K. Since R3 has not configured adaptive shaping, it's ignoring the beckons and sending as much as it can. Let's shut R3 and see if R1 increases its sending rate. We'll simply shut S00 on R3. and see what happens to the rate from R1 back on FRS. Still at 192. Now we've increased to 199,000 bits per second. Up to 208. With R3 shut down, R1 is no longer receiving beckons and is slowly increasing its sending rate. Back up to 226K. As we have seen in this presentation, Cisco routers are capable of performing advanced frame relay switching operations to enforce service level agreements. The policing feature can drop or mark inbound traffic based on its rate. The congestion management feature can drop out-of-profile traffic or mark the congestion notification bits. Remember that you must use the connect syntax for your frame relay routes. That topic is covered in the frame relay switching presentation.